Let's wind some filament. For a while now, I've been trying to come up with the best way to transfer filament from one spool to another, either to test that filament on multiple machines or to transfer it from a larger spool to a smaller one. And there's a lot of great community designs out there to get this done, but I remember quite a few years ago seeing a design that I wanted to check out, this one, so I thought I'd start there first. That design being the Filawinder. The Filawinder kit is available from Filastruder. It is somewhat expensive. I got it on sale, so I thought why not give it a try first. It was designed to pick up filament from the Filastruder so you can make your own filament, but it should also transfer filament from one spool to another. In fact, you can stop using the geared motor on the winder and still use the servo to help lay it down in layers by spinning it with an alternate source. So I thought this would be a good kit to start with. Even if it didn't work for our purposes, it would be a learning experience. So that's what we're going to do today. We're going to walk through all the steps on how to build a Filawinder kit. And you might be asking yourself, why do I need to know how to build a Filawinder kit? Well, you probably don't. There's probably not a lot of users out there that need a filament winding system, but one, I'm going to build it anyway, so why not make a video on it? And two, I'd like to alter this design just a bit to make it fit my needs a little bit better. And it might be helpful for you to know where the design came from originally, and it might help someone out in the future. So let's go ahead and get to building. And here's all the parts that you'll get with the kit. I did elect to get the kit that didn't come with printed parts and print my own. We have several pieces of acrylic for miscellaneous things. We'll see more of that when we start to build. You'll get all the wires and switches that we're going to use, a servo, a gear motor, an AC/DC power brick, our control board here, and our sensor board here. We have a 5-watt laser. Remember all the safety precautions. Anytime you're working with a laser, this is pretty low powered, but you still don't want that anywhere around your eyes. We've got a ribbon cable, a potentiometer, a knob, our hardware set over here. This has some bearings and a bunch of M3 hardware, a couple of M8 nuts and washers. We have both sizes of PTFE for 4mm, 6mm, that's for 175 and 3mm filament, a threaded rod, and then we also have some foam adhesive bumpers and some rubber adhesive bumpers and a magnet running around in here somewhere. So that's the extent of the kit, as well as you get all the documentation on paper, which is always nice to see. And then here are all the printed parts. We have the control box cover. You will need some support for these tabs. We have our drive gear, our spool gear, our spool hub. We have our support base. You want to print this as solid as possible. This has to be pretty rigid. Our support bar. We have our servo mount and our filament guide and our laser mount. This one also needs to have some supports. I did supports everywhere because there's some through holes that should be supported when it's printing. And I wanted to mention on these 3 parts right here, the guide arm, the servo holder, and the laser mount, there are acrylic alternatives in the kit already. Now, just by looking at the kit, some of these printed parts might actually be better than the acrylic ones, especially the laser mount. But you don't have to print these 3 parts, but you might want to go ahead and print them while you're printing all the other parts, just in case you need to swap out to one of these instead. I might consider these as another option down the road if I'm having some issues. Also, it is pretty apparent that all these parts were designed for ABS plastic. You notice it most on the spool hubs fitting those 608 bearings. They have allowed for a little bit of shrinkage of the plastic because the bearings aren't necessarily all that tight in there. That's a pretty easy fix. We can change the scale for PLA to make it just a little bit tighter. Just wanted to let you know what I found. So let's build this thing. We're going to take our geared motor. We're going to use our acrylic mount here. We're going to line up that motor in this hole so that we can see the mounting holes in the motor through these slotted holes. And we'll tighten that down with some M3 by 10mm screws. We probably don't want to tighten that down quite yet because I'm guessing we're going to have to adjust that. We'll take a drive gear. The directions say use a hex nut. I'm going to use a square nut because I think that's going to work a lot better. And an M3 by 10mm screw. We'll just lightly screw it in for now. That's what's going to keep it on the motor shaft. And we'll slide that gear onto the motor shaft so that the screw is on the flat side of the shaft. We'll just put it on and lightly tighten it for now because it's probably going to have to be adjusted. Next up, we'll mount our control board. You want this Hall sensor facing the motor, and we're going to use M3 by 12mm screws, 1 on each corner. We'll just use some M3 nuts on the back. Then we'll take our threaded rod, We'll put one of our 8mm nuts on here, spin it down just a bit. It's just going to go through this acrylic and mount. We'll put a washer on it, and then it's going to go through the acrylic on the board side. We'll put another washer on it, and we'll secure it with this other 8mm nut. And our threaded rod is on, and then we'll get our acrylic base. This whole motor assembly, this piece of acrylic, these two tabs are going to slide in right here. And then down here, we're going to slide in a square nut, and then through the bottom to hold this on, we'll use an M3 by 25mm screw. Like so. As always, when nutting up acrylic like this, don't get it too tight or you're going to break it. Next up, we're going to put the bearings in our spool gear, one in the front, one in the back, but it's going to have one interface layer here in the center that you can just break out with a set of pliers. That's been cleaned out, so we'll just push one bearing here in the front, like so, and one bearing in the back. And then we have the magnet. I believe this one triggers the Hall sensor. You can kind of flip it around and it should correct itself, but we need to know which side is the North Pole. So it looks like this side is the north. I'm going to mark that like so. And that's going to go inside this gear. We can come back and glue it a little bit later after we know that it works, but the north side is going to face out. Just like that. I'm going to slide our spool gear under a threaded rod. The drive gear will need to be adjusted to mate up with the spool gear. We'll have to make some adjustments before we start testing, but I'm going to wait until I figure out this whole thing before I do all that. Next, we're going to mount our support base over here in these two slots. We want it facing this direction. For now, we're just going to use two M3 by 16 screws, like so. We'll just put some M3 nuts on the back. And we'll mount our support arm on the hinge side here with an M3 by 25mm screw. Like so. We will go ahead and put another M3 nut on the back of this, but it does have to spin freely, so this hinge has to move. A nylock nut or maybe two nuts together might be a better choice for this going down the road, but we'll see how that works. Next, we'll put our servo on our acrylic mount plate with four M3 by 12mm screws. Like so, M3 nuts on the back. And that assembly will mount in these two slots right here, the ones closest to the spool motor. Right like that. We'll use a square nut down here on the bottom of the mount. And an M3 by 25mm screw from the bottom. And the servo's been mounted on. Now we're going to take our guide arm and our cross-shaped servo arm, and we're going to attach it to these slots right here with the sharp screws that come with the servo kit. You need the socket on the servo arm to face out. So it's going to go just like this, and you're going to put those sharp screws in from behind to hold this on. There's one just to show you what we're getting at here. I'll go ahead and put the other three in, just like that. So in this servo, we should have roughly 180 degrees of motion. I'm just going to put the arm on, and I'm going to push it all the way one way until it stops. About right there. And since we're going that direction, I'm going to say that that's all the way out on this side vertically. And then we'll push it the other way. And then when we get to the stop on this side, we're roughly horizontal in that direction. We just have to be able to turn the servo enough to get the whole spool, because that's how it's going to guide the filament onto it. So that should be good. We'll go ahead and put this small screw in the center. We can always adjust it later. And our servo arm is on. Now we have to move to soldering. We have 3 push buttons, a couple of switches, and a potentiometer to wire up. And we have 2 wires with the DuPont connector for each one of these. For the switches and the buttons, doesn't matter which wire goes where. We're just going to go through and solder a pigtail to each one of these 5. And then on the potentiometer, we have a 3-wire set that'll go here. So we'll start with one of the buttons. We'll put one of the wires on each terminal, and we'll fold it over. Like so, and we'll just put a little bit of solder on each one to hold them in place. Just like that, and we'll repeat that for the other 2 buttons. All 3 buttons are done. Now we'll move to the switches. The switches are going to be exactly the same. Just use one of your 2-wire leads. Doesn't matter which wire goes where. Fold them over, and put a little solder on them. First one's done. Both the switches are complete. Now we can put our wires on our potentiometer. It really doesn't matter which wire you use, which side, because we can just flip the plug over to install it to change the direction if we need to. Just make sure that white one goes to the center lug. We'll just feed the wires in through the back, and we'll put a little solder on it to hold it in place. And the potentiometer should be good to go. Now back to our switches and our wires. You can try to twist these wires if you want. You can use a drill. I'd rather just put some sort of covering on these after they're installed just to keep them in place and make it look a little cleaner. but you can do whichever you wish. We do need to mark these connectors and buttons so we know which one's which when we go to wire it up. For the buttons, we need a left, we need a right, and we need a center. And the switches, we need an auto switch, and we need a power switch. So we'll build our control board here. We'll put our left switch on the left side. We'll put our right switch on the right side. Did I say switch? I meant button. Put our center button in the center. We'll put our auto switch on the left side, off, down. And then our power switch on the right side. Just like that, our potentiometer will go in this hole right here. We'll slide it in from the back and put our washer and our nut on. And then we can slide our knob on. So our control panel is all set up. Back to our base, I'm going to slide all of our wires through this hole. They're going to run over here to the control board. We can mount the control box with some M3 by 16 millimeter screws. Control box is fastened down. Now we can run these wires through this hole right here. And to give it a little extra room on the bottom for those wires to clear, we're going to use these little feet. We'll flip it over and just stick one on each corner. This will also keep it from moving around. And while we're under here, we're going to use this spot right here for a zip tie. We'll just run it from the top, swing it around the outside. I'm going to make sure all the wires are nice and flat. Pull that tight, just to keep all the wires out of the way. Like so. Then we can flip it back over. Now our last set of wires with the DuPont connector on them, I'm going to plug those into these top two pins right here. These are the ones for the geared motor. It doesn't really matter which pin goes on where, because if we need to flip it, we can later if we want to change the direction. I'm just going to pull the motor wires up and around, up to the motor, and I'm going to clip them short, pretty much as short as we can possibly get by with. We just don't want these motor wires getting in the way. About right there, I clipped them short, but left enough so that I can strip the ends. We'll put our positive wire up there, our negative wire down here, and we'll put a little solder on just to make sure they stay put. And we should be done with our soldering. Now we'll get to wiring everything else up. The next set of pins underneath the motor, those two should be our auto switch. We'll plug that one in. Our right button will go into guide min. That's the next set of pins. Our center will be the calibrate. That's the next set of pins down. Right here. The next set of pins is for your servo. The signal wire is your orange wire, so that will be the one up top. Your brown one will be going down. The next set is for guide max. That'll be your left button. And then on the other side of the board over here, these top two pins, that's your power. So that's the power switch. And your potentiometer goes in the 3 pins below that. Now for the test, I'm just going to wind some filament on the table right here. There are 2 configurations for it. You can use it vertically or horizontally. Someday I would like to see it mounted to the wall so I could just let it do its thing while I'm busy doing other stuff. But for now, I'm going to set it up for the vertical position. So this acrylic piece is going to hold the PTFE tube to give you just a little bit of tension on the filament while you're winding it. For the vertical position, I'm going to put it right here. And then it's going to be held on with a square nut and an M3 by 25 millimeter screw. Just like before, square nut goes in the slot, and a 25 millimeter screw comes in through the bottom. Now whichever size of filament you'd like to wind, I'm going to do 175. Grab that PTFE tube, and I'm going to cut off 35 centimeters. And from the spool side, I'm going to feed the PTFE in the bottom hole to the outside, and then bring the other side around and feed it back through from the outside in. Again, that's just to give the filament a little bit of tension while it's pulling it through. Now we're going to build the sensor body. Like I showed you before, there's printed parts for this, or you can use the acrylic ones that they gave you in the kit. I'm going to build the acrylic one for now. This portion has the round hole that holds the laser. I'm going to put it on this side. The other side that holds the sensor, I'm going to put it on this side. There's a small score right here to tell you which side the laser side goes on. And I'm going to put all 4 square nuts and M3 by 25 millimeter screws in from the bottom to secure these 2 panels. And if you use the square nut like I did on the drive gear, you might have to source 1 more square nut. No worries, I happen to have an extra, but just keep that in mind. There's our laser and sensor holder. We put our laser in the round hole side. You might have to separate these a bit with a screwdriver to get that in there. It is a tight fit. I got it in there, but I'm not super happy with how that's mounted in there. It's just a little bit off. Might have to take that back apart, but we'll see how it goes. I did go ahead and run the wires through the hole in the bottom here. We'll take our ribbon cable, we'll plug it into our sensor board. We'll run the rest of it through the side of the mount here. And then we're going to put our laser wires on this terminal right here. It is really small. You're going to need a really small screwdriver. This side is positive, so red. This side's negative, black. And we'll secure our sensor plate with two M3 by 12 millimeter screws. One top, one bottom. Our sensor screwed in place. We'll secure the laser wires down here with a zip tie. We just don't want it to get in the path of the laser and the sensor. Like so. Then we'll go ahead and zip tie the ribbon cable to the back over here, just so it doesn't move anywhere. Right there should be good. And we'll stick these foam feet to the bottom of the housing, just to make up for the zip tie gap and those screw heads. That should keep it from moving around a little bit as well. And then with the remaining piece of our PTFE tube, we're going to cut 4 pieces, 90 millimeters long. That'll be sort of a guide inside that sensor housing. There's our 4 pieces, and they will go down in these holes, 2 on each side. I'm going to kind of adjust mine so the curve goes out. We don't want it to interfere with the laser. 2 on that side. And the ribbon cable from your laser sensor is going to go right in here on your board. And on our spool hub, we need to clear out this 1 layer of filament like we did on the spool bearing. And then we can put our last 2 bearings in here, 1 in this side and 1 in this side. Now's a great time to go around and tighten up any screws that we didn't before. This drive gear is going to be pretty much self-aligning because of this V groove. It should keep this gear in place. So just line up the drive gear with your spool gear. I push the drive gear pretty much all the way down. There's about 1 millimeter of gap in between it and the motor. And then I tightened up the set screw. Then I lowered the gear motor just so it meets up with this gear and it's going to keep it from moving side to side. And then I tighten these screws up. Then you can go ahead and put your empty spool on, line it up on the hub. And then on the other side, you can put your hub on and then use one of your M8 nuts to secure it. So you're going to want this spool pretty tight. Go ahead and tighten this nut up with your pliers. You don't want it to slip while it's trying to spool the filament. And then when you've got it snug, you can bring this side up to kind of hold it in place. Then we can plug our power adapter in right here. Before we turn it on, we're going to flip this left switch to auto. That'll keep the spool from turning when we get ready to turn the power on. So let's turn the power on. The servo is probably going to move just a little bit, and also the laser will be on. See that right there? So now we're going to calibrate the guide for this size spool. You don't want it going too far left or right. So make sure your knob is right in the center. Hopefully when you put it on, you spun the potentiometer all one way and set the needle to that direction. So now you kind of have a center baseline. We're going to hold the left button, and then we're going to adjust the knob to set the left side of the guide. So we'll move it up just a bit. And I'm going to put it right there, pretty close to the edge of the spool. And then we'll hold the right button, and I'm going to move it over with the potentiometer right to the edge of the right of the spool. We can adjust this a little bit later if we need to. And now we're going to hold the middle button and take it back to center. So the last direction that it turns in when you're holding the middle button, that's the direction it's going to go. So it should start this way and go to the left position, then come back, go to the right, and vice versa over and over. Now we can turn the potentiometer all the way down, and we'll go over to manual mode by flipping this switch. So we're getting ready to calibrate the laser, but before we do that, you need to make sure that your laser is pointing in the right direction. You can spin the lens and actually change the direction of which way the laser points. It's going to be pretty hard to see on camera, but just make sure it's running vertical with all your sensors. And now that we're in manual mode, we can hit this center button, and for 5 seconds that will allow us to calibrate the laser and the sensor. So we're going to push this button and then run the filament we want to wind in between these two so that you can see what the shadow looks like. So we'll hit this and just run it back and forth a few times. And that should save on our control board. And when in manual mode, we can go ahead and run our potentiometer up and make sure everything's working correctly, the spool's turning correctly. Looks like the spool's turning, and every time that magnet goes by, it's going to move that servo just a little bit over so it gets a nice even wind. And if we go back to auto mode, it's going to continue to turn if it doesn't see any filament. If it starts to see it, that means it's gone tight and it shouldn't spool it anymore. So let's try this thing out. Remember, I'm just interested in transferring from spool to spool. So let's just feed some filament on a spool over here through our Filawinder mechanism. And we'll go through our guide. I'm just going to loop it on the outside of the spool. After it gets a few winds in, then I can pull this through. Let's just see how this is going to go. And we'll switch to auto mode. So the first try was a failure, but here's what I figured out. This spool gear was too close to this acrylic. So to fix that, I added an extra M8 nut that was in the kit to pull it out a bit, and the spool was actually hitting the control board. It was so close, so that should solve that problem. Also, my original drive gear was just a little bit broken. So I printed another one with 4 shells and 50% infill, and that seems to be quite a bit sturdier. Making that correction, I pulled this gear out from the shaft just a little bit to still meet up with that gear. Everything presses up against that nut, so it should be nice and tight when we put the spool back on. So let's put our spool back on, and we'll give it another try. So take 2. This time, let's try some manual mode. We'll power on, and let's just turn it up just a little bit to see if we can start picking up some filament off that other spool. This time it looks to be much more successful already. We got a couple layers on. Let's go ahead and turn it up and see how fast it'll go. That's top speed. It's not very fast, but it might still be useful for a couple things. I don't need it to be all that fast. I got some time. So it does look like it's spooling successfully. Let's go ahead and slow it down. And let's switch over to auto mode. Now auto mode, it's going to use the sensor to tell if there's slack in the filament. This is really meant to be used when you're making filament. So if there's slack, it'll spool more. If it's tight, it'll spool less. So let's just switch it to auto mode. You can kind of see as it's moving up and down, it goes a little faster, a little slower. It is going to be quite a bit slower than manual mode, I'm guessing. If we push it up a bit, that's going to put it into the laser light, and that's going to assume that it's being pulled tight, so it should slow down, and it does. And then back out of the laser view, it'll keep pulling. So, auto mode appears to work. And that's it, we're winding some filament. Now this will probably suit my needs. I would like to see the manual mode just a little bit faster for transferring filament. I really don't intend to make filament, so I don't need the laser sensor so much, but this was a great learning experience, and it'll be a great place to start. Hopefully you found this at least entertaining. If you did, please consider giving it a thumbs up or subscribing to my channel. If not, leave your thoughts in the comments below, and as always, thanks for watching.